Welcome to Atega Tech. Today we'll continue with our three-phase circuit analysis. Today we'll be analyzing a three-phase unbalanced star circuit with a neutral wire. So mostly with these connections, it's always a star connected circuit. So let us look at some tricks. So with the three-phase four-wire feeding unbalanced star connected load, the three phases are unbalanced and they do not have the same impedances in all the branches. They do not have the same impedance. So because of this, there is always a neutral wire connected in the middle. So the aim of this, we will need to calculate the current in all the three phases, and after calculating the current in the three phases, we simply add all the currents up to calculate the neutral distance, the current in the neutral branch. So using this formula, so the current in the neutral branch will now become IN here will be equal to the current in the branch 1, branch 2, and phase 1, phase 2, phase 3, or phase A, phase B, phase C. So this is how we simply analyze it. So without wasting much time, let me just take an example and we'll see how to calculate it. So this our example says a three-phase four-wire system has the following data. Supply voltage is 415 volt. Z1 is 8 plus J0 ohms. Z2 is 0 minus J 8J ohms, and Z3 is 0 plus 8J ohms. Determine the load currents and the current in the neutral. So here we'll have to find the current in each of the phases. So we know that this is our line voltage. So since it's a delta, we need to calculate the phase voltage. These are all delta circuits. So for unbalanced circuits, all of them are star circuits. So they are star. So we have to invoke the star. We said for star, the phase voltage is equal to the line voltage divided by root 3. So we'll get our voltage, our phase voltage as 240 volts. So after calculating our phase voltage, we now need to let us name the current that will flow through this Z1, Z2, Z3 impedance as IA, IB, and IC. So to do that, to find the current, that is IP1. So the phase current 1 is equals to the phase voltage divided by the phase the impedance of that one. So we'll name it as IP1. So to calculate IP1, just simply the phase voltage over the impedance. Then doing that, we get our answer as this. To calculate for IP2, so it becomes the phase voltage divided by Z2 to get this. And to calculate IP3, it is the phase voltage divided by uh, V3. So you might ask yourself, why is it that the first one I just did 0 degrees? As we said, in the motors, the phases are arranged at 120 degrees apart. So we have the 0 degrees. There are three phases. The one is in 0 degrees. The second one is minus 120, and the last one is plus 120. So we just do that to get these our answers. So after getting these our answers, we now simply add the currents to find the I and the neutral. So IN is equals to IP1 plus IP2 plus IP3. So doing that, we can now just add the IP1, IP2. Doing that, we simply get this. Then our final answer becomes 82 amps. This is how we simply calculate it. So when you please how someone might be asking, how do we add these things? You have to change your calculator to complex mode. So you change it to complex mode in order to be able to add the angle and the phase so that you get this 82. Because if you add it anyhow, you wouldn't get the 82. So change your calculator to complex mode. So let us take our next example. Problem 2 says in a three-phase four-wire system, the line voltage is 400 volt and the resistive loads of 10 kilowatts, 8 kilowatts, and 5 kilowatts are connected between the three lines and the neutral. Calculate the current in each line and the current in the neutral conductor. So here they are telling us that the currents, the loads are 10, 8, and 5. So let us name Oh, and the line, they've given us our line voltage, and since it's a star, let us calculate our phase voltage. Our phase voltage is our line voltage divided by root 3. So 400 divided by root 3 will get 231 volts. So since we've gotten 231 volts, let us name um, the current that will pass through the 10 kilowatts as IA, and the 8 as IB, and the 5 as IC. So doing that, naming them like that, we now simply calculate IA by just dividing the 231 volts by the the, the 10 kilowatt. So IA here is now equals to the 10 the So since we are now calculating for IA, we know that this formula is, we already know this formula. We've invoked this formula several times. So just make I the subject. So IA here is divided by the P, the power that we are considering, the voltage, the phase voltage, then cos phi. Cos here is 0. So they didn't give us the power factor. So cos 0 here is 1. So we can just take it out. So it is 10 times 10 raised to the power 3 divided by 231 times 1. Then we get this 43.3 amps. Then we also calculate for IB. IB, we just change this power. Everything stays the same. So IB, changing that, we get this. And for IC, changing that, we also get this. After doing this, we now need to now add to calculate for the neutral, because we've now calculated for the current in each of the phases, the three phases, IE, IB, IC. So we now need to calculate the current in the neutral branch. So in the neutral branch, IN is equals to the sum of IA plus IB plus IC. So adding everything up, this is what we get, and we get our final answer as 189 amps. So this is how we do. So please always remember to change your calculator mode to complex if not that you will not get the right answer. Always in this one, if you are calculating, change your calculator mode to complex mode. Okay, with our last example, it says a three-phase 400-volt four-wire system has a star-connected load with ZA is equals to 20 plus 20 J ohm and ZC 0 plus. Then calculate the current and the current in the neutral conductor. So we need to calculate the line current. So since it is connected in a star connection, we have to find the line current. And to find the line current, we have to first of all find the phase voltage star. Phase voltage is equals to the line voltage divided by root 3. And the line voltage was 400. Divided by 400, we get 230.94 volts. Afterwards, we can now calculate for the line current. So to calculate the current in the first one, ZA, so ZA is equal to the phase by the the distance, the impedance in that branch. So our VP was 230.94 angle 0 divided by 20. Then we'll get this angle, this answer, 11 point this. And to calculate for IB, the current in the B branch is also equals to 230 divided by the uh, the values there. We simply change this into phases. So I hope you guys know how to change this one into phases. You can use the calculator. In the next series I will show you how to use the calculator to change this to phases. And to also calculate IC, we change it to phases. That is 230.94 angle 0, then here 10 angle 90, which is equals to. So after doing all these calculations, we can now add IA, IB, and IC, because we now know the values. We add this, and this. So IN here is now equals to IA plus IB plus IC. So that's the current in the neutral branch. Then we get our answer as 26.39. So this is how we simply calculate our uh, three-phase unbalanced load with four feeding wire. So this is how we calculate the current in the neutral line or the neutral branch. So kindly take your time, go through, and you will be Thank you very much for watching. Kindly remember to like, share, and subscribe for more content like this. Bye.